virtual reality, that's not the virtual reality I refer to, but I still brought that picture. Because to an extent that resembles someone who is blinding himself on purpose by putting something in front of his and saying something that's not real. So the reality of VNFs, we talk about virtual services. The reality of VNFs is that actually they are provided on real hardware, right? There is a real server underneath that virtual device. And if there's any information, it is conveyed on real ducts, even though it might be a virtual service on that duct. And they're part of real services. No matter if the services are provided over dedicated devices or over virtual devices, those are real services that consumers consume. So what actually makes them virtual? When we think about virtual services, from a customer's perspective, they don't really care if it's virtual or physical. What makes them virtual from a telco perspective, from a CSP perspective, is that they use shared resources. We do not use a dedicated resource for that service, and that they're provisioned quickly through software and not manually through manual configuration of devices or actual physical delivery of devices. So what I really want to discuss is how can carriers make use of virtualization to provide services faster? Because by the end of the day, we as a CSP, we do not view NFV or SDN or other buzzwords as the goal. The real goal is to deliver services faster, to respond to customers' requirements, to respond to customer demand, which customers require services that they deliver fast and can change according to need instead of the current fixed connectivity or fixed services that not only connectivity that are delivered. So I'm going to discuss the services, I'm going to discuss the process around the services, and I'm going to discuss the orchestration framework, because those three fundamental basics are what really needs to be aligned in order to get services done automatically, in order to allow virtualization to let us meet our customers' requirements. So in a very abstract manner, I will define services as belonging to two families of services. There is connectivity services, which basically means conveying information between nodes. I don't care what happens at the nodes. I don't care what kind of information is conveyed. I'm just focusing on delivering the service from one node to another. It could be layer 0, layer 1, layer 2, mobile, wireless, whatever, just the connectivity. The other kind of services is what I can define as nodal services. And nodal services would be things that happen at the nodes, and I don't really care how I bring the information into or out of that node. It just happens at a node. It could be compute, it could be storage, it could be processing of information. These are things that happen either at the edge of the connectivity or maybe even at the center or in the middle of a connectivity service. This is kind of like a very, very coarse breaking of the services into two major families, and I think that pretty much any service you can think of can belong to one of those, one or the other. So if you look at the nodal services, those that ignore the connectivity and just rely on the service itself, well, there is the application, and there is an orchestration that delivers the application, and we activate the VNFs, or one or two VNFs, and if the VNFs need connectivity, they either assume it exists because it's in a data center and there's this huge backplane that provides connectivity from any point to any point, and if it's not in one data center, then we'll just turn it into IP and send it over the internet. It will find its place. The issue is that the internet, as we all know, even though people say it keeps improving and it's very good and performance is good enough, internet is not good enough, and sometimes you run this GoToMeeting call or WebEx call, and one of the users suddenly sounds fading or stuttered. Internet is just not good enough for all applications. It might be good enough for 90% of the applications. For 10%, at some times, they're not good enough. So now we come up with a solution to overcome the limitations of the internet. So we either fix our applications to be able to overcome the erratic behavior of the internet, and they sometimes succeed, or we invent all sorts of hyper de jour such as SD-WAN, which allows us to get some extra breath until we actually need to fix the connectivity, but we eventually evade the need to really manage our network, manage our connectivity, to deliver the connectivity element between the VNFs to achieve the end-to-end service. So I might want to take a different look on services, because we have the nodal services, we have the connectivity services, and we have the real services which you deliver to the customers, which are bundles that include both connectivity and nodal services. And those are the services which customers really consume. As telcos in the past, we focused only on the connectivity. As VNF providers, we currently focus only on the VNFs. As CSPs, we need to bind them both together to an end-to-end service, which could be content delivery, such as voice or video. It could be banking transactions that need security on demand. And it becomes even more interesting because usually it will be initiated on a mobile network, and it will need to end in the cloud. And mobile and cloud are typically not a CSP domain. There are other domains that we need to interface with to deliver the end-to-end service. So a few words about managed connectivity. So for virtual services to turn into reality, we need to manage, as just mentioned, both the connectivity and the applications. And we should stop avoiding the task of managing the network. We keep doing that because it's a heavy task. It's a very, very heavy lifting task to actually manage our connectivity. And it's very easy to push everything over the internet, but the internet basically for us as CSPs is a race to zero. The revenue might remain, but the margins just keep shrinking. So how do we manage connectivity? That's a tough one. You see, this picture is actually taken out of our, I think it's about a 10 years old picture from our presentation 10 years. So we were already managing connectivity 10 years ago, providing VPNs of all sorts at PCCW Global, but we were doing so manually. It was too slow to adapt or to match the current customer requirements. So we'll get to that. We need to get those things done faster. I mentioned three elements: the services, which I've just mentioned, the process, and the orchestration framework. So the previous speaker spoke about the process, the legacy process, and the new process. This is basically our legacy process, and obviously the new process that evolves around dynamic services will look a bit different. Why will it look a bit different? Because inquiry in code will typically be just one thing. It will be through a portal or through a predefined service. You just click a button and it works. Either if it's not available, it just doesn't show up in your screen as an option. Ordering, again, it's not an ordering, filling up an order form. It's click and that's it. Fulfillment, automatic. Assurance, I'm not sure there will actually be assurance in an automated virtual world. If it doesn't work, you just hang up and redial, right? That's the same as you do with the phone call. If you're trying to set up a video conference over your phone, it doesn't work, what do? You disconnect and dial again. So assurance will take place, but not by calling your vendor and saying, hey, my line isn't working good, and now take it down for 2 days, fix it, and give it back and pay some credit. You just disconnect and reconnect. Your supplier will figure out, if you're disconnecting and connecting too often, that means something is wrong. We need to fix it. It's not by me calling them and telling them something is wrong. Billing, well, billing will still need to be there, of course. Change management is about doing things, changing things in real time. So this is the process really in real time, in coarse manners. And now we're talking about the multi-domain environment orchestration framework. I brought this MEF picture because this is probably the only current multi-domain orchestration framework out there in the market. All other orchestration frameworks are focusing on a single domain. And they could be very nice implementations, but they are a single domain, and real services are not limited to a single domain. Real services span across multiple domains. I'm not going to go into all the various elements of this diagram, and by the way, through my roles in MEF, and I'm also holding a few positions in MEF, I think this diagram needs to progress a bit. It's about 2 years old. But figure in mind, we need to superimpose the service and the process on that diagram. So this is what we need to do. We need to get that service provisioning, all those steps, aligned across the customer, service provider, and the partner. And the reality is even more complex because this is the actual reality. Each of those parties has their own orchestration platform and their own stages, and we need to make sure that everything runs smoothly between all those parties involved. It's a very complex task to achieve, especially if you want that done automatically, because we do that manually today. Anyone has a guess of what would be the typical lead time from inquiry to service delivery? Idea? Any idea what would be the typical lead time from inquiry until service is actually delivered and handed over to the customer?
3 months.
3 months is from order to service delivery. So from inquiry, it would be 3 extra months, because until the customer decides whether our service is good enough. So we talk about typical 6-month cycles from initial inquiry until service is delivered. But thanks for volunteering to with the number. You weren't that far off. So how do we actually make that happen? I'm switching to orchestration. You talk about end-to-end orchestration, and I think that's a very interesting topic, because in an academic life, it's very easy to think of an end-to-end orchestrator that sits somewhere above and orchestrates the end-to-end service. But the reality is that the service, I'm just taking here an example of a service that starts in a mobile device in Australia with a user of Telstra Mobile for this case, and that tries to connect to an app that resides in AliCloud somewhere in China. And to get there, since Telstra Mobile is confined to Australia, they need to contact Telstra International that takes it out of Australia. They need to meet PCCW Global that then has a connection to AliCloud. Obviously, you can change the names, but that's a typical scenario, that the service spans across 3, 4, and even more operators along the way. And we need to activate service on demand, right? We do not want to use the public internet because society it's not good enough. So we want to activate a managed service in real time from the mobile handset, which means we need to fix the 5G RAN to run managed connectivity on the wireless part and extend it on the mobile backhaul part, and then extend it over the terrestrial part, and then extend it into the cloud and into a managed VM that provides the required performance. We need to do all of that end to end. How do we manage all that? How do we make that thing happen? So, with the almighty orchestrator, we have a top-level orchestrator that then configures all the network components along the way. And this is a great academic approach, but it doesn't work in real time. Doesn't work in reality, in reality, because this is virtual reality. We think that AliCloud will accept a third-party instructions into how to configure the network, or we think PCCW Global will accept, would expose its network and accept configuration commands from a third party. Not going to happen. Not going to happen. So carriers will neither provide visibility nor allow control of the network to any third party. It's only going to be by our own parties. So we'll need to figure out a way to manage and orchestrate end-to-end in a manner that parties will accept. So the reality, the real life, we take the same scenario, but now instead of having a single orchestrator that orchestrates everything, we'll need to have a federation of orchestrators that will actually activate service on each network by itself, and then the orchestrators will need to figure out a way to speak with each other in order to deliver the end-to-end service. That east-west federated orchestration is a task that we as an industry need to solve, but first we need to understand that this is what we need to solve. If we keep trying to solve the problems through a single hierarchical orchestration, it just ain't going to happen, and we're going to keep using the public internet as a solution because that kind of just works. So I mentioned 3 fundamental vectors, the services, which are basically made of info models, interface profiles, which basically what do we want to deliver. Then just sample services that we might want to deliver. There is the process, the life cycle process I mentioned earlier. That will need to evolve into a real-time process. So that's the how, and obviously inquiry, ordering, provisioning, billing, etc. All that will need to happen. And then the orchestration framework, which basically means who are the players involved in delivering the end-to-end service. So it will be the customer, the service provider, possible partners, and there might be internal elements within those that will need to speak with each other. How can that happen? How can all those speak with each other? The real problem is, if you don't speak the same language, if you don't use the same language, what happens is that I might ask my service provider to deliver an apple to Timbuktu. And in response, I will not ask him. I will ask him if he can deliver an apple to Timbuktu. I wouldn't even ask him to deliver. Just ask him, can you deliver an apple to Timbuktu? The response I'm expecting a response which will be either yes or no. And if yes, it's going to cost you that much. But if he doesn't understand what I asked, the response will be him delivering me an orange in Vienna, because he didn't figure out if an apple was an orange or an apple. It's just this round thing you eat. He didn't figure out if I was asking, can you, or please do. And didn't understand if Timbuktu is Vienna or Africa, because we're not speaking the same language. The good thing about it, at least, is that he will send the bill to someone else. So we need to have standard service definitions to make sure we speak about the same language and we understand what we're asking for each other. We need to have a standard process to make sure that the ordering and the fulfillment and the management and the monitoring are properly aligned between the players, if you remember the 3 vectors there. And we need to have a standardized orchestration framework to make it all work together. So, for virtual services to turn into reality, we need to manage both the apps and the connectivity, right? We should stop avoiding the heavy task of managing our network. But then you might say, it's going to take years, right? It's going to take years. Yeah, well, you're right. It's going to take years, which means we need to start tackling the problem. Because if you keep delaying the problem, it will not solve itself. Then I would want to say, then why don't use open source, It takes 3 years to write a spec. Well, I haven't seen open source produce useful results in any shorter than that same time frame. So we'll need to figure out a way to work together and deliver both specs and use open source and specs together, kind of like a top-down approach and a bottom-up approach, and meet somewhere in the middle. It's not one way or the other. It should work together. End of the day, open source can only be as good as the spec it implements. But on the other side, a spec can certainly learn from the wrongdoings or good doings of open source projects. So basically, for virtual service to become a reality, roll up your sleeves and start doing the needful job. Come and help us write standards. And there are various fora that do that. So please join us there. That's it. Any questions? Just 2 minutes for questions. Go ahead.
So interesting, you have 4 there that you say standards, MEF, TM4, etc., etc. Yet the industry itself has shied away from standards. With ONAP and OSM and all of those things, they're developing those, and almost they're becoming de facto standards. Why do you think that is?
First, they're not becoming a de facto standard. They're becoming a suggested operating system that solves a single domain problem and a very specific problem. I would also say I do not really agree that the industry has shied away from standards. It's just that the open source projects they're kind of like a hype du jour. They're kind of a hype du jour. So, it's very exciting, you go, let's write code and standard will appear. The fact is that it doesn't. We've seen the open source projects. Honestly, they haven't really produced any useful results that industry can really use. If they had, it has been after a very, very, very long years of iterations until they've been able to produce something really useful. So they're good as an academic study, as a way of maybe thinking of you know, coming up with an approach, guiding the standards where they need to be. But standard work continues. I mean,